Hey, hello there, and welcome back to another Advent of Code video. So today I have to get going in a little bit, like maybe at 18:30 at most. But I really want to see. Oh, look at that! I haven't, I hadn't seen the Advent calendar after the solve of the last one, which was the 18 puzzle, and now we have. What was this? The Gear Island factory. Catch up with like parts for something, metal parts, machine parts, something like that. But it seems to be working now. That's awesome. And at least in this little time that I have, I want to see if maybe I can squeeze something for the part one of the next one. Let's see. Oof. I don't know if I will. This looks already complicated for for parsing. So okay, a plenty or a plenty. I'm not sure how this is pronounced, but lots of, I guess. The elves on Gear Island are thankful for your help and sent you on your way. They even have a hang glider that someone stole from Desert Island. Oh, that someone was us in this daily puzzle. Since you're already going in that direction, it would help them a lot if you would use it to get down there and return it to them. Great, so we go down as we went up. As you reach the bottom of the relentless avalanche of machine parts. So that's what we are seeing here, a relentless avalanche of machine parts. You discover that they are already forming a formidable heap. Don't worry though, a group of elves is already here organizing the parts, and they have a system. To start, each part is rated in each of 4 categories. X is for extremely cool looking and musical. It makes a noise when you hit it. Aerodynamic, A, and S, shiny. And the acronym stands for Xmas, of course. And it's a very nice way of organizing things. I guess I could use it for, I don't know, organizing random stuff in my apartment. Extremely cool, musical, aerodynamic, and shiny. And if it doesn't match any of those, like, is it worth having that thing around? I would say no. Then each part is sent through a series of workflows that will ultimately accept or reject the part. Each workflow has a name and contains a list of rules. Each rule, like this sounds like lots of parsing. Each rule specifies a condition and where to send the parts if the condition is true. The first rule that matches the part being considered is applied immediately, and the part moves on to the destination described by the rule. The last rule in each workflow has no condition and always applies if reached. Okay, consider the workflow X, and yeah, it seems like between curly braces you have rules. Each workflow has a name and condition. There's a list of rules, yeah. This workflow is named X and contains 4 rules. So I guess rules are divided by commas. If workflow X were considering a specific part, it will perform the following steps in order. Rule X greater than 10, 1. If the part's X is more than 10, send the part to the workflow named 1. Okay. Otherwise, if the part's M is less than 20, send the part to the workflow named 2. Okay. So I hope that the rules are always like simple, something less than or greater than a number, hopefully, and not just, well, we will see. Rule this thing, otherwise, if the part's A is more than 30, the part is immediately rejected. Okay, so capital R means rejected. Rule A, otherwise, because no other rules match the part, the merge is immediately accepted. Okay. If a part is sent to another workflow, it immediately switches to the start of that workflow instead and never returns. If a part is accepted, sent to A, or rejected, sent to R, the part immediately stops any further processing. Okay. The system works, but it's not keeping up with the torrent of weird metal shapes. The elves ask if you can help sort a few parts and give you the list of workflows and some part ratings, your puzzle input. For example, so these would be the workflows, and these are part rate. Okay, so each of these, I think, represents like a part, and the Xmas numbers correspond to that, like qualities of that part, I guess. The workflows are listed first, followed by a blank line. Then the ratings of the parts of the elves would like you to sort. All parts begin in the workflow named in. Okay, so here there should be a workflow named in. Great. In this example, the 5 listed parts go through the workflow through the following workflows. Okay, the first part then goes in this QS and then accepted. Okay, so far it's a lot of prose, but it sort of makes sense, I think. Ultimately, 3 parts are accepted. Okay, adding up the Xmas ratings for each of the accepted parts gives 7,540 for the part with X787. So yeah, having this 4,000 something for this one, yeah, and 6,900 something for this one. Okay, adding all of the ratings for all of the accepted parts gives the sum total of this. Okay, sort through all of the parts you have been given. What do you get if you add together all of the rating numbers for all of the parts that ultimately get accepted? And then the puzzle inputs is a bunch of workflows and a bunch of parts. Okay, so actually this doesn't look like the logic would be very complicated, or that it would be like algorithmically or computationally expensive, but it requires a bit of parsing for sure, and quite a bit of modeling also. So let's look at the rules in this example. Yeah, all the rules are greater than or less than and a number. There's no like S greater than M or something like that. And I guess that will be, well, we will see if we get any parsing error, I guess. So okay, cool. Let's try to sketch this out and see how far do we get. Let's jump into the codes. We can close everything, do our usual thing of starting with the templates. This is going to be day 19. What was the name? Workflow what? Aplenty or aplenty, however it is pronounced. Aplenty. And we're gonna copy the inputs too. So this is template copy 19. Our inputs is gonna be pretty big. It's all of this mess. Sure. The sample is gonna be 1, 2, 3. This guy, and this sample output should be this number. Okay, so we need to do some parsing in here. Parsing of parts and parsing of the inputs. Okay, what should we do? Yeah, let's just start from the top down. We're gonna have the input, right? Let's extract right away a function to parse these things, and I want to call this thing like workflows. You can have like a collection of workflows and a collection of parts. This is let's call it parse input. Why not? And pass in the input. And this surely will be a fallible operation. So let's do this. Generate this. Sure. Let's return a dynamic result of what? Well, of what? It will be a tuple of two things. The workflows, I think, since each workflow has a name and then like a list of rules, it's just could be like hash map with the names on the keys and then the you know, hash map, well, the keys are the names and then just a vector of rules, I guess. Although like the last rule should be a rule that doesn't have a condition, sort of. So how would we model the rule actually? I would say like, yeah, a rule is a condition and like an output of that rule. Let's see how. Consider each rule specifies a condition and where to send the part if the condition is true. So condition and yeah, destination could be. It's like the if and the then. Yeah, I would say something like, if I had to model, and I think I would like to model these things. So you could say something like struct rule will have a condition which we're gonna see what it is, and then in output, which again could be a thing, I guess. Outputs can be like a workflow name or accept or reject. Those are the possible outputs. So let's actually write those down. An output can be like go to a workflow, go to yeah, workflow, and have well, we can use string slices, but if we do this we're gonna need lifetimes, which is great. Let's bite the bullets, why not? What could go wrong? All the workflow names seem to be like pretty simple things, like three letter strings or 2-letter strings. So we could have something simpler like integer IDs, and then I don't know, yeah, something to map those integers, or yeah, we could have something, but for now let's just use the strings. So yeah, an output can be this, or accept, or reject. Okay, great. Let's order it in this way. So that's great. You don't like this because missing lifetime. Well, sure, we can do that. Sure. And then a condition. What would a condition be? A condition would have like letter, I guess. How are we going to model the parts? Well, we could have a struct with all of these 4 values, x, m, a, s. Or I guess for that, I mean, it's sort of a bag of values. So I'm tempted to say that a part is just going to be a tuple of just numbers like this, or even better, I think, just a static array of, and let's use 64-bit numbers. Why not? 4 numbers, just four freaking numbers. And then the conditions, I guess, could be the index of this array, like x, m, a, s. It's just a number to index those things. Could be greater than or less than, and then a number itself. So could be that. It could be that. Greater than. Yeah. Let's see, because all the conditions seem to be sort of the same. Struct condition. It's gonna have left-hand side, say, can I have like a little enum here? X mass. Is this valid syntax? Probably not. How do they call these things? Categories. Yeah, but this is like let's call this thing category index, and just have an index for like from 0 to 4, which would correspond like x, m, a, or s. Then operator, which is going to be its own thing, and then the value, I guess, which is just going to be a number. So are there negative numbers? Probably not, so let's use 64. Okay, and finally, enum operator can be greater than or less than. Okay, look at all of that modeling. And we're probably missing the workflows themselves. So we could make the workflows be like just a vector of rules. But how do you model like the last rule that always matches? Well, you could have a condition that is always true, or maybe have a I don't know, this condition. You could have like 2 types of conditions, for example, or a rule that is a special type of rule that always matches. But I think it would be better to specify that, like model that in the workflow itself. Like if we had a struct workflow for this, that would have the rules, and this is going to be a vector of actual rules, and then like a default thing or fallback, default fallback, whatever. It's just gonna be an output. It's not a full-on rule, and all of these require, lifetimes are kind of one of those viral things, sticky things that you start to use them and then they propagate up. It's like async code. Not great, but yeah. Okay, and now we could say that this thing returns a collection of workflows. It will be a hash map of workflow IDs, which will be string slices, and workflows. Yeah. Then I can bump the font size probably, because I don't know how readable that is on a video. And yeah, this is the workflows part, and then the parts themselves are going to be a vector of part. And look at that. This is just this sounds like very like analytical coding, like so for like analysts that just says, well, these are the classes and things, but they don't write any like working code. That is just what we did, but hopefully this is more or less correct and we can write things now based on that. So how are we going to parse these things? We can have, first of all, let's have the workflows part and the parts part of the input. Instead of like this, let's call it input. It's just going to be the input split once by double new line, of course, and we expect this, or it's going to be an invalid input. Okay, that's the first thing. Now, for the workflow input, let's say let's workflows be workflows input lines, and I think I'm having like, yeah, it seems like my Rust analyzer is having a stroke or something, because it's not like really understanding things. And this also happened in the last video, so I may have a problem with Rust analyzer. I go live, restart server. I don't know what that does, but let's go, buddy, you can do it. It takes some time apparently, but don't you know about the bird? Everybody knows about the bird. Bird. The bird is the word. Now, okay. Too bad. Let's see if I can program in Rust without autocompletion. That's a tall order. So we're gonna have something to parse the workflow. So let's have a line. Let's say parse workflow. Sure. Can probably even say workflow parse line, and yes, sort of, not quite, because I want to have this thing collected into like this should return a tuple of the workflow ID and the rest of the workflow. So simply do parse workflow. We can then see what we put on the, like, as methods on the structs and what not to. We're going to collect. This probably can fail. Most likely will fail. But let's say, okay, those were the workflows. Let's now say, oops. Well, let's now say that this is sorry, it's gonna be the parts it's the parts input, and just going to say parse part for this. And I don't know if try collect is what I want, like if this is fallible, I don't know, probably. And then let's return workflows and parts. So yeah, if in this video I can do all the parsing, I think I will be happy enough. So what's your problem here? Result, but found it. Okay. I wasn't propagating this app. Yeah, it wasn't a problem on Rust Analyzer. It was a problem in like the problem was between the chair and the monitor. Let's generate a parse workflow, which will give us back a tuple of string and workflow. Sure. No, actually, this should give us a result of these things. Result of these guys. And you're still unhappy because iterator try collect. Oh, import this thing. This is from itertools. So use itertools. Because there is an unstable feature in Rust that is also called try collect, and will do the same thing, but it's not yet stabilized. So okay, great. And let's also sketch out this parse part for sure. This thing should return a result of a vector. No, result of a part simply. Okay. And these, what's your problem? Isn't this the types that we wanted to have? This should be an okay thing. Okay, great. Now we are full of warnings. Once you don't have more errors, you start to have warnings. That's great. I don't know why it's told me to inline this one, but not this one. Weird. But okay, let's see. What should we parse first? Let's actually try to, well, the lines should be, the parts I think should be easier. And I just want to use something like AOC parse numbers with this thing. Parse numbers returns a vector, which is like okay. So basically this thing and try into, let's say, parse numbers, this may fail. Then we don't need to propagate this. Let's see, try into. What am I missing here? Boxed in. Try from slice iterate. Huh? Yeah, we want this thing to, let's say, let part be this, and then just have okay part. Okay. This parse numbers doesn't do what we want to do. This is just splitting by commas, and then doing map parse, and then collecting. But what we can do, since we are only parsing positive numbers, I think we can do something more sophisticated that will also work for the previous day that used this, which I don't remember what it was. Day 12. Sure. So basically what I would like to do is get everything that is like, split by anything that is not a number, like that is not numeric, and just keep the numbers. So we can say, hey, split, instead of this pattern, by digits, by is ASCII digit, even. You don't like these because, yes, FNCHAR. What's your... okay, it should, well, let's just simply say the character and say ch is ASCII digits. And you need a, I don't know why this needs a, actually I want to split by things that are not digits, okay. And this, I know that this split is not like split white space that removes all the contiguous white space. Like if there is multiple things that are not numbers, like in this case, like I want to use this because I want to just get rid of all of this, all of this, all of this, everything that is not a number, and just keep the numbers, you know. So we can do that, but this thing will return some slices that will be empty. So let's just say filter the slices that are not empty, and then parse them as numbers. And this, I think, should still work for well, we are having some compilation things, but should still work for day 12. So yeah, it seems like day 12 passed. Day 19 aplenty didn't pass because that's what we are doing now. Then a bunch of compilation errors, and day 19 again, but the other things passed, so this should be fine. Sure. And it's like a more, instead of just parsing numbers, this is sort of like extracting numbers from any string and not caring about anything else that is not numbers, which is fine. Sometimes I want to do this kind of thing. And the parsing of parts should be fine like that. I would like to maybe like even comment this and here say like, hey, I don't know, return a hash map, a new hash map, and not care about that, and just print here what parts we got. So print line, have trouble sometimes typing parts as this. Okay, after all of this, let's finally do some running. Being day 19, aplenty for the inputs of 19 sample. Okay, so we have some numbers. It didn't explode. The sample says 7872655. This, yeah. Okay, yeah. That parsing of parts worked, and I also want to parse the workflows now. So let's go now. Let's leave that printing. Let's come back here to the actual parsing of workflows. I'm gonna return that. And now, how do we parse each workflow? This is gonna be more involved, I think. I am almost tempted of like learning how to use like an actual parsing library like nom or something like that, but for now I will just do it like splitting and yeah, just doing it the cave person way. So we should have this and we should have this. So what if we do, first of all, split by either opening or closing curlies, and we're going to then I don't know what this actually gives us, so let's actually print this print line. Let's just print it as debug and do this and collect into like a vector. Sure. I don't know what this T is doing here. It's weird that there is also a collect tuple on. Wow. Didn't know that that existed. If we run this, it's going to, yes, hit a to do, but did we print something? Yes. px pixels. This part and then an empty thing. Sure, I think we can get rid of the empty here. Right? Yeah. Let's filter the strings that or slices that are not empty. Okay, and we're gonna just give me this. What do we want to do? Actually, this, like, I'm wondering now, like, I just learned about this collect tuple, but would it do? It's exactly equal to the tuple size, then the tuple is returned inside sum, otherwise none is returned. Huh. Okay. This is sort of kind of what we want, I think. Kind of, because we have filtered this and we can say like okay, or invalid workflow, and here this should give me, well, we propagate this up and then this will give me the workflow ID and the like workflow string somehow. And at least here I already have the ID, like the first part, which will be the ID. So let's say and workflow. This is not the correct type. This should be an OK of this. Sure. Workflow is not the correct type. So we now need to parse the inside of the workflow, this thing. So we need to like split by commas and parse rules. Yeah, okay. This, I guess we can sort of say delegate and say, hey, workflow. Now let's parse this. Yeah, parse and then pass the workflow string, and this could fail, I guess. So let's propagate any error up, and we're gonna keep delegating like this. I don't know if putting the inputs right below the types is good. Maybe I would like to have like all the types, and then maybe the impulse, I'm not sure. Sure, this is gonna be S, and this will give us a AOC result of a workflow. So what do we do then? S, we are going to split by commas, that's for sure. And these are basically the different rules, strings that we need to parse. So let's call this thing let rules. We can collect. Should I use start using collect back, because it is useful to have collect back instead of having to define the type of where you want to collect into. Like iter_tools is pretty useful. So we have that, and I want to have at least one rule, which is like the default thing. So let's have like a match here and say let we're gonna have what, like something and a default be these rules, which again we're going to need to do the matching thingy, or else say, hey, expected at least one default rule. Okay. And how did we capture this? I think with something like this, rules, or the other way around. Rules add this. Okay, like extract the first. Yeah, that's what I want. And now we want to return a workflow of workflow. This had fallback was the name. So fallback one fallback rule with rules and fallback, and actually an okay thing of these two. And of course these are the incorrect types. So let's say let's rules be rules iterate and map. This will be just a chain of delegation. We're going to pass to rule parse this thing. We're going to collect into the specified type, which will be this. Rule parsing most likely will fail too, and then the fallback is gonna be an output parse of this fallback string, and again this probably will fail, so let's add this. Great. So now this almost compiles. We just need to generate these little functions. So no, not extracting the variable, generate parse function. Let's again move the impl down here. This should return a AOC result, and I hope that the lifetimes won't screw me over. Do I need to specify a lifetime here? Most likely no. Yeah, let it inherit the lifetime from the parameter. This parse, please generate it. And it's gonna live here. Do I need to say the lifetime here? That is annoying. If I just use this thing, Do you still care? No. What are you caring? What are you complaining about? Implicit elided lifetime is not allowed here. Like, yes, can I just put an anonymous lifetime here? Yeah. Just let Rust take care of things. And this is a parsing of an output, AOC result of outputs, which I think also needs a lifetime. We'll see. When we reach the lifetime errors, we'll see what we need to do. This also needs a lifetime, right? Yeah. Starting to get tempted to use just numeric IDs for workflows and have some way of, like, when parsing, having a workflow map or something. Or they could just be like the index of the workflows in the initial array or the initial input. But maybe that requires like 2 passes. I don't know. It doesn't seem that complicated, but let's pass the lifetimes for now. We can refactor that later if the lifetimes are a problem. Sure. So we need to have these 2 parsing things so we can be able to like have a successful parsing. So how do we parse? Let's start with the output, which is the simplest one. So this should be actually, I don't know if this is fallible, you know, because we are going to do map this string, match this string, basically, match S, and if it is the string A, we are just going to say, hey, output accept. If it is R, we're gonna say output reject. And if it's anything else, like we don't know, we're gonna say output workflow of that anything. So that should be the return. It's not, cannot fail really. Great. So 1 parsing done. And now the parsing of the rules. So let's take a look at this. So rule then have a condition and an output. Great, that seems easy. Let's say let condition and output be string split once by colon and okay, or validate rule, propagate up, and then the, what am I missing here? Yeah. Then we're going to delegate this to, again, let's say let condition be condition parse this thing, which again is going to be fallible, whatever, and output is going to be, this one already exists, so output parse of this output string. Finally, we're going to return an OK rule of condition and outputs. All right, and the last thing to generate this parse function. So yeah, it's a chain of long chain. I don't know if actually this is the last thing to generate. To be honest, at this point I'm already confused. So let's have the condition here. It's gonna be take a string. It will return an AOC result of condition. And what do we need for a condition? We need yes, this category. So we're basically going to, what do you want to do? basically first character, second character, and then the number. That's what we want. Right. Yeah. So how do we go about that? I'm tempted like to work in bytes here instead of characters, just to make things easier. It's not like I like that, but yeah, it sounds easier to me. Although then I will have to parse the number itself. Let's have it be as simple as possible. So let's say what is it that we call the first thing? Category, yes. Category is gonna be like the first character of a string, something like this. This is probably not great, but let's go for it. This is gonna be the operator, it's gonna be the second one. And then we're gonna have the number or the value is gonna be the rest, basically. So from 2 onwards. And yeah, I think that is fine. The category, we need to convert it into a category index. So let's say let category index, and it's going to be match of category. And if it is x, we're going to say 0. X mass is going to be 0 to this is the index to the part number thingy. And if it is anything else, let's just return an error. Invalid category. Great. This is what we are going to return at the end, so it's going to be an OK condition of category index, sure, and the operator and the value. So we also have to parse these things. Value can just be this and parse it, just be the correct thing. What's your problem with this? I think I'm getting screwed by precedence here. Yeah, I was. Yeah, let's do one thing at a time here. So here we are extracting these things, then we convert them to the correct thing. So let's say let OP be match this OP string. I guess we could delegate this again to like operator dot parse, just to be consistent with what we have been doing. And then finally let value be value.parse. Okay, this now surely should be the last delegation. the last the last thing to do. So s gonna return an AUZ result of operator. Come on, we almost have it. Match the s and say if it is, what do we want to say? Okay, if it's this, it's gonna be operator less than, and similarly if it's greater than, it's gonna be greater than, and if it's anything else, it's gonna be an error format. Come on, invalid operator. Yes. Propagate you up. You probably need to be wrapped in OKs, right? Yeah, expected result. So let's do that. Great. So I think that is all the parsing that we needed. Let's just run this thing, and we're gonna have, okay, it actually ran without errors, without hitting any of the error checks. So I'm not printing these things. Maybe I could, although that will require a lot of derive debug statements. We're going to need like derive debug here and in lots of places for you and for you and for you and for you, and that's it, right? With that you can now print. If we do that, look at this mess, but does it actually look like what we've done? The first, oh, these are not in order because it's a hash. It's a hash map. So let's look for GD over here. GD is this. It's only one rule. The first rule is that the condition of the category index 2, so this is A, XMA, yes, this is index 2, should be greater than the value 333, yes, and the output is going to be reject for this rule, and the fallback is also reject. Awesome. So I think the parsing is working, and that was it for today. I have to get going right away because I want to get to the climbing gym. I'm already a bit late. But yeah, this is just a video of the parsing for day 19. If you have been, thanks for watching. I hope that this was somehow enjoyable. Probably not, but see you later. Bye.